Very good evening, everyone. Can you hear me? Let me know in the chat. Can you guys hear me? Very good evening, Arad. How are you guys? So yeah, I think it's still not better compared than earlier. But yes, I'm not feeling weakness today. But yeah, still my nose is running. But with my voice, you guys can understand today that not feeling that much weakness or you know that throat is also good today. But yeah, nose is still running. So I'm still using this inhaler because weather is changing and these things happens with everyone. So once we go from summer to winter or winter to some summer, it happens. Hope you. I'm hoping like you guys are okay. Everyone is doing great. I remember in in last discussion, some of you guys were feeling fever as well. Very good evening, Joseph. Very good evening, Sanvaz. Hello, Ankit. So all of you guys are doing great. Health wise, everyone is okay. React versus Angular. Nice question. Which is one better? Both are good. See, no, React and Angular both are good actually, and you it always goes to it always goes on the requirement basis, and I don't want to give you any political answer or any diplomatic answer. I would say that people are using most of the requirements right now. If you are the beginner and if you want to start learning React or Angular, so go with React because a lot of requirement I have seen for React, and I found Angular a bit complicated as compared React. It's not true, Ankit, because Angular has more features. It's more rich. You do not go outside to look for any libraries. Angular has everything, so that's why you might face like Angular is little bit complicated to learn. Yes, it has a little bit slope to learn, but I personally feel that both are good. In yesterday class, in last question once explained about the char code at. Sure, Joseph, sure. So we'll wait for 1 or 2 more minutes and then we'll start. Okay, guys, just 1 minute, huh? So which one do you use? I have used both actually. I started working with Angular 1, Angular JS without before Angular 2. Angular JS was in the uh, in for us for the developers. Angular JS first come, and after Angular JS, they have totally changed Angular 2. So I have started working with Angular JS. I think in 2018, I started with Angular JS. No, Angular JS is not latest. Angular 10 after Angular JS, they started giving they started giving a name as Angular 2, Angular 3, Angular 4, something like that. I'm not sure about Angular 3. Then Angular 10. I think right now Angular 10 is there, right? I have not seen it in very long back about the Angular. because I'm fully right now working on Node.js, so I'm not fully aware of. But when I started with Angular first or Angular JS, that mostly known as Angular JS, and then I have also worked on Angular 7. That was the very latest version of Angular. Totally everything was different there in Angular 7. So I work on that as well. Then I work on React as well. In two of my projects, I work on React. I think the current project I'm working on PayPal, that's also in React. Total code is written in JSX. So so that's what I'm saying. I have worked in both, and I have not find any difficulties anywhere. Okay, guys. That's not true. That's also do not go with that. That's see, if you are like a starter, like if you are going to start learning any of those languages, any of those frameworks, start with React. That's not true. It's mostly used for enterprise app, or both can be used anywhere. It's not that, but yeah, people has started moving towards the React because somehow React has is been little bit easy compared to the Angular, because Angular follows more on class based structure. A lot of things are class based there, but in the React you will see React also has a lot of class things, but a lot of things you can do with the functional approach as well. And we like functional approach because we can create a lot of functions, like we can create components also as a functional in React, right? So now they have provided hooks in React. After I think React 17, they have started providing hooks. So with the help of hooks, you do not need at all class in React. You can do everything in functions. So that's why people, because functions are very easy, right? And in the JavaScript, function is a highly function is high class citizen. In function you can return that function as a you can pass that function in another function. That function is a rich in JavaScript. So that's why react React make that taken that approach of functions, and highly people are using functions in React. So that's why I think that could be the reason people have started using React. And Vue.js is also there, which is the combination of React and Angular. So they have taken the best part, both of them, and then they are using the Vue.js. But if you are new, I would say start with React.js. A lot of jobs are still there for React.js. I have seen. Not sure about the Angular. I'm not that much confident about the Angular right now. But I'm not saying Angular is bad or anything like that. A lot of applications are using Angular, is still using Angular. So that's my take on that. So before moving further, I think Joseph has asked about the care code at. So let me see what was that question. We can jump into that one. And before that, Joseph, so let me show you the what care code add does. Okay, it's a JavaScript function. Okay, let me show you. So I think char code add, right? Yeah, char code add in JS. You guys are able to see my screen? Let me know in the chat. You guys are able to see my screen? Thank you, thank you. So the char code add, I think it just see this is my string hello world, and tags.char code add, it will take the letter from this and it will provide you the ASCII value of it, or Unicode value of it. That's what is Unicode value of it. You can see 72. So it is providing the value of H, which is 72. So in one of our previous class, I told you about that A to Z, all of the letters which are available in the keyboard, they have some binary number for that, or they have some Unicode character for that. So your machine can interpret it. So that's what the char code add gives us the value add. So like when I'm doing, if I remove it and if I do capital A only, Joseph, and if I want to, and here we pass the index. This zero is index. We can, because this is a big string, right? If I write ABC, this is a big string. So we can pass here indexes. Like if I want to check the char code of one, so I will be getting the B. I will be getting the char code for B. Let me show you. It will be 66. Now if I want to check for A, I will do that. Put it here 0. Index it's 65. So that's what we were doing here. And I think in the question where we were looking into the char code add, we were looking for one value which we want to save it in our somewhere in the stack or queue. Correct. So that's why we were using the char code add. And I remember, I think Likhit has pointed it out that we can also use the parse int there. Mostly people do use char code add for string, like when we have any string there, and when we want to do any operations mathematically on that string with each letter, when we want to do some mathematical operation on that, so that's why people go for char code add, because it will always provide you unique value. A itself is a unique, and char value of a, it's also unique, but char value will give you number, so now you can do some operations on that number. So that's why mostly people go for char code add. Understood, Joseph? My doubt is for every letter you were passing char code at 0. Okay, let me check that. Which was that problem, Joseph? Do you remember which problem we're talking about here? I remember a little bit about that. It was in the stack. Let me see. Collision one? Last problem. What was the name there in the last problem? It was the, uh, I think, yeah, it's a collision one, right? No, no, no. Collision one was the first problem. The last problem was, I remember that was good problem actually. Uh, Let me check. Computer expression, no. Daily temperature, no. Okay, I have opened the slide. Ah, it was collision only. Ah, okay, it was collision only. No, no, no. It is not the collision one. Let me. I have already opened the slide. 1 minute. Of K deletion. Yes, K deletion digit. Yes, minimum digit. Yes, that was the question, right? Yeah. So let's see that. Correct. So here, what we were doing, the char code at 0. Yes, because you see, Joseph, this character is giving only one. See, this character, it's only coming as a single there. This ch of num, it is coming as a single letter every time. So that's why we are doing at the 0th index. We do not have any. We do not have any whole string there. You can see here also we are taking the top element from stack, and what we are pushing in the stack, only one character. You can see in the stack everywhere, wherever we are pushing, we are only pushing one character into that. So that's why we are only checking the 0th index, because there is no 2 or 3 more letters. Yes, we have the single letter every time. You can see both of the scenarios where we are using the char code. Here also we are taking the single character. Let's ch of num, and here also in stack, wherever we are pushing ch only, single character. Understood now, Joseph? Why we are using the char code at 0? Okay. I think meanwhile Parag question was yeah. Can we cover coding part of asteroid question, which we have done in the last class? Got the logic, but cannot able to understand the code. Asteroid question. Okay. I think, by the way, we already have tomorrow revision class. I was asking to Ansul that do we really need any revision class, because we have not covered any theoretical topic from the last, I think, 10 days. We are totally doing the problems. So he told that some people have some doubts. So do you guys really have a lot of doubts on the lots of doubt which you want to do in the revision, or we can go for the next topic as well? I will answer your question, Parag, but I just want to quickly ask this, and at the end of class wants to update Ansul about it. So yeah, so no theoretical part. So that's what I also think. But what about you guys? Want any revision or doubt class tomorrow, or you guys want to go for a topic? Because I think the next topic is the binary tree for us. Okay, I will wait for your answer. In meanwhile, I will go for Parag question. In meanwhile, so coding part. Can we call coding part of a stride question? Okay, I think it was collision one, right? Yeah, it was the collision one, right? Yeah, in meanwhile you guys can think about it and give me your answer. Okay, so see, Parag, I remember in the collision part, uh, the question was given to us that there will be one array been given to us, and in that array we will be having the size of asteroids. Okay, and with the size of asteroid, they will also give us some signs, positive and negative signs. With the positive signs, we will understand that that particular asteroid is moving onto the right side. On the right side, eh? This is my right hand, so that's why I'm doing right side. Okay, and the negative sign was representing that the asteroid would be moving into the left side. Okay, then they told us one more condition, that two different directions, asteroid will never meet. No, no, no. Two same direction. Yes, sorry for that. Two same directions asteroid will never meet. And with this one line, we have concluded two theories. And the first theory was the opposite direction asteroid can collide. And we have also seen some scenarios where the opposite side of asteroid were not colliding as well. Like if you remember the example of -1, 1, because -1 started with left direction and one started with right direction. So in that scenario, we have also seen that the collision was not happening. And if we rotate this, if we rotate the same values, 1 comma minus 1, if we do 1 comma minus 1, now you will see 1 is moving into the right direction and -1 is moving into the left direction. Now they both will collide. So we have seen the two of these situations there as well. Okay, that was only the thinking part. Now let's move into the coding part. I think what we need to check. So what we started with, if our stack is empty, so first we will keep the whatever the size is. If see whenever our size was negative, then only we need to think about that there could be some collision, right? Parag, oh, where was that? Yeah. So right, Parag, whenever there is any negative size, in those scenarios, there was the chance that we could get the collision. So that's why whenever we are getting any positive number, we were simply pushing it to the stack. So that's what you can see at the first line. Whenever we are getting any positive numbers, we are simply pushing it into the stack. Correct. Now, once we got a negative number, now we are checking it. Now we are checking that if already some positive numbers already inserted into the stack, like just consider like 2 and 5. These are the positive asteroids which are moving to the right directions. They are already put it into the stack. Correct. So in the stack, 2 is there and 5 is there. Now there is one -10 is coming. Correct. -10 is coming, and you know the conditions, you know the logic, because the -10 size is bigger, so he is going to eat all these below 1. Correct. You remember this, Parag? When the size of negativism is bigger, it is going to eat all of the positive one which are smaller in size. So that's what the first logic is doing. So I was first checking, is there any asteroid available in stack? Oh yes, it is. Then I'm checking, is the asteroid which is available in stack, it should not be negative. It should not be negative, because you remember some of the scenarios like -2, -1. If these are the asteroid which are coming first rather than the positive one, so those we do not need to look for them, because negative are not going to eat each other because they are in the same direction. So that's why I'm checking here that my whatever right now in the stack top, whatever asteroid reside there, yes, the top element should be positive. Then only they will collide. Negative will never be collide. You understood that thing, Parag? Because see, in this else part, we are only coming when there is any negative. When there is any negative. So if there is any negative coming and on the stack top already a negative is there, then it means they both are in the same direction. They both are running in the same direction. So they will not collide. So that's why I'm checking this second part also, that in the stack top, there should not be any negative asteroid size. Okay. And after that, my condition of the size, I'm just checking the size. Wherever I'm getting the lesser size positive asteroid. I'm just popping in them out. I'm just eating them. That's what this popping is doing. Now, once we covered this condition, this condition will stop here. This condition will stop here. All of the smaller one, all of the smaller one, all of the smaller positive one will be eaten out. Will be eaten out. Correct. Now, these are some of the other conditions. These are some of the other conditions. Like the first condition, just for inserting, you if you remember about two scenarios, right? If the result is you remember about it, -2, -1 scenario. If you are telling that you have understood the logic, so in the logic I have explained you, if any negative asteroid is coming first, in those scenarios we just need to insert those them as well, because negative negative cannot eat each other. So that's why these are some of the conditions which are doing that part. The first one, the result is stack dot length is equal to 0, or result top if it is less than 0, like -2. First time, just consider -2 comes into your picture, -2. So -2 size of asteroid -2 is in the stack top, correct? Now -1 is coming. Now -1 is coming. So now for that scenario, I'm doing this thing. That result stack length -1 less than 0. If the result stack top is less than 0, right now that stack top is less than 0 only, because -2 is on the top. So now -1 will also be inserted. So this condition is for that. And if my stack is empty, this could be the scenario for -2 only, because if first time -2 is coming, there will not be anything in the stack. So that in that scenario, this condition will run. And the else if condition, this condition is running for that scenario where we have seen 8 comma -8, same size, uh, asteroid, but with opposite signs. In those scenarios, we were seeing this. We were simply what we are doing. We are simply comparing it and popping it out. Yeah, popping it out like 8 comma -8. So 8 will be pushed into the stack. Now, for 8, for -8, it will not go into this condition. It will also not go into this if condition, because the result stack length is not 0, and result top is not minus because it's a +8. So now it will go into this part, and we will simply eat that 8 which already exists, because you remember that if both are same size and they are colliding, they both should be exploded. So that's why the last condition is there. And then we will return our result stack. Whatever left in the result stack, that would be our answer. Understood, Parag, now? Great. Any doubt, Parag? Are we good with that? Now you understood the logic as well? Good, right? If you still have any doubt, let me know. I think this is definitely going to help others as well. Might some people might be having doubt. Okay. Yeah, very nice, very nice. So now let's go for our assignment problem. So who has done the assignment problem? Joseph, you were asking about the assignment problems. Have you tried those assignment problem? Who has tried it? Okay, and meanwhile, by the way, Vishal has said something. Vivian could give us some more time to practice what have been taught so far. But in that revision, okay, okay. I totally agree with that. But I'm thinking, because we are daily doing the problem solving and we are already doing the practice day by day. And wherever you guys is stuck, I could see, if you have stuck in any of the problems, definitely we can talk about them in our revision class. Okay, what about others' thought? In meanwhile, also answer me if anyone has tried assignment problems. Joseph, Ankit, Vishal, Parag. A lot of less people has joined. Hariharan, Sahwaz. Yeah, I've seen Sahwaz and Nayan are talking very less. Arad, you're also not talking anything. What happened, guys? Not able to understand anything, or you guys are just behind? Oh, yesterday you tried parenthesis. Okay, I tried the ones we did in last class. That's totally right. Phone and switch, laptop. Okay. Practice the problem which are done in class, all the six problems. Great. Just thought about the logic. Okay. Okay, so I think I can say that Vishal has tried it because he mentioned that the ones we did in the last class. I tried the ones we did in the last class. Oh, no, 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 no. He was talking about the problems which we did in the last class. Okay, so he also has not done the assignment question. Joseph is also saying just I thought about the logic. See, guys, let's jump into the assignments question. I think that first of the assignment questions, we have already done it. Given a stack S, you need to reverse the element in the stack using another empty stack S. Have we not done the reverse of stack? You tell me, guys, have we not done the stack of reverse of stack? Yes, we have. So if you guys have read the assignment question, you guys must think about it that we have already done this. But see, here little bit twist in that question. Because in earlier problem, if you guys remember, I already have the code for it. If I go into the stack.js, if I show you the reverse code, you guys remember that we were using the uh, recursion there, right? We were using the recursion there. We were deleting all the elements, storing into the temp, then we were inserting them at the inserted bottom. Inserted bottom. That's what we were doing there. But here, little bit twist. Here they are saying to you, they are okay with giving extra space. They are okay with giving you extra space, and that is another stack. So now you need to think about the logic. Now you have one another stack. What is the way we need to follow here? Okay. Question is similar. You can do the reverse there as well, but now they are saying you have one stack like this. You have one stack. Where is it? Let me see the problem. 2, 4, 5, 7, 8. Yeah. So in a stack, element will be like this: 2, 4, 5, 7, and 8. Correct, guys? That would be our element. And then we have also given this is stack 1. And then they have given one empty stack to us. Correct? And now they want us to reverse the element of this stack. And after reversing, our output or output stack or stack 1 should look like this: 8, 7, 5, 4, and 2. Right, guys? That's what we need to do. That's what we need to do, right? We have given one stack, and then we have also given one stack 2. This is the stack 2 here. They have given us 2 stack here. This is stack 1, this is stack 2, and then they are asking us return us stack 1 with this output. So now let's think about how we will use these 2 stack here. How we will use these 2 stack there. Okay. Definitely pop and push is there. Okay, so let's think, guys, about it. So first, what we will do here, see, if we like simply think about it, so if we will pop out all the elements now, if we pop out all the elements from there and push it into the stack 2, will it help? Will it help? Let's see. This is our stack 1. I'm writing as S1, and this is our stack 2. Okay. Now, if we popped out everything from here, so first 8 will be go out. First 8 will go out. 8 will be pushed here. Then I think 7 will be pushed here. Then 5 will be pushed here. Then 4 will be pushed here. Then 2 will be pushed here. Right? Now, if they are asking like simply return, now the one solution could be simply return as S2 because it's already the reverse one, right, guys? It's already the reverse one. But no, they are asking you need to return the stack 1. Now what to do, guys? How to get the reverse these same elements here in stack 1? Will this approach work? Now if I again do the pop here, Again, like 2 will be inserted here, 4, like again we'll get the stack 1. Is it going to help? Simply doing popping and pushing? No, right? We are going to get back at the same result. Yes, insert at bottom. Somehow we need to do the insert at bottom here. That's totally right. We have to do the insert at bottom. So, okay. Uh, so now let's think about how we will do the insert at bottom. So this approach directly will not work. Okay. So what we will do, guys, we will be taking out first element out of it, like let's like let me create it. See it little bit like with the attention. Give little bit your attention here. Okay. So first we'll take out this element. Yes, definitely we are going to use the recursion. Definitely. So first take out this element and store it into temp. Temp will be 8. Temp will be 8. And then all of these element push it into the stack 2. All of remaining element push it into the stack 2. So 7 will be here, 5 will be here, 4 will be here, and 2 will be here. Okay. So this is S2. This is guys S1. This is S2. Now after doing that, our S1 will be empty. Let's take it here. Our S1 will be empty. Am I right, guys? Am I right, guys? So first what we did, we have popped out first element and stored it into one variable temp, and then we popped out every element in S2. So you can see first 7 has been pushed here, then 5, then 4, then 2. Now we have S1 empty. Everyone agree with that? Joseph, Parag, Hariharan, everyone? Arad? Okay. Yeah. So now what we need to do, now our stack is empty. Push this temp. Push this temp first. So now we will push the 8 here. Okay. Now we have pushed the 8 here. And after pushing 8, now push all these elements. Now push back all these elements. So now these element will be pushed back here. So now it will look like 8, 2, 4, 5, and 7. You guys see that in first iteration we have make R8 at the bottom. We have inserted R8 at the bottom. This was only first iteration. This is only one iteration, and same iteration we need to follow. This is the first iteration. In the first iteration, first let me now repeat it. First we have taken the top element of stack in one variable temp. Then we popped out everything from here in stack 2. So 7 first came out, then 5, then 4, then 2. After popping everything out, our stack 1 was empty. Then we inserted temp 8. Whatever the temp variable was there. Now 8 is there. And after that, we are putting everything back what we have in S2. So now you can see 2, 4, 5, 7. And now with after first iteration, you can see 8 is coming at the end. Everyone understood this thing? Anyone has any doubt here? Are we good? We have to follow the same step again. So now we have in our stack 1, this is stack 1. Now our stack 1 look like this: 7, 5, 4, 2, and 8. This is our stack 1. And here we have our stack 2, which is empty right now. Correct? Now again, take this top element, temp is equal to 7. Correct? Then take all remaining element except the last one, because this is the second iteration. This is the second iteration. So we'll only take these 3 elements, not the last one, and push it back into the S2. So it will look like 5, 4, and 2. Now again our S1 is empty. Again our S1 is empty. Push it. Push this element here. So now, no, not empty. 8 will be here. Sorry, 8 will be here, not empty. Sorry guys. 8 is already there, right? We have popped out only these elements. Correct? So 8 is there. Now push the 7 there. So 8 and 7 is here. Now, once we push out the 8, 7, push everything back into this stack. So now this will look like 8, 7, 2, 4, and 5. Now you guys can see that two elements has been come at the last. You can see we started with this. Now you can see all two elements after second iteration. This is the first iteration. Now this is the second iteration. Now you can see all of the two elements has been came out in a reverse order. Understood, guys? The second iteration also. Everyone understood the second iteration also. Now let's quickly go for third iteration. Now we are going for third iteration. So before third iteration, our S1 looks like this: 5, 4, 2, 7, and 8. This time we'll only pop these three elements. So first, temp is equal to 5. Now these two, 4 and 2. This is our S2. Our S1 will look like this now: 8 and 7. Now we'll push this temp to here. Same approach. Whatever we followed in the first, we are going to follow the same. 8, 7, 5. This is our S1. And now this S2 will again go back to here. Similar way: 8, 7, 5, 2, and then 4. Correct? This is our S1. Now we'll go for fourth iteration. I think this should be the last iteration. Fourth iteration. So 4, 2, 5, 7, and 8. This is our S1. Temp will have 4, right? Temp will have 4. And now it will only take this one. In S2, 2 will come. Now in our S1, 8, 7, 5 already there. Now 4 will be inserted here. So 8, 7, 5, and 4 is there. Now put this element also. 2, 4, 5, 7, 8. I hope that was the answer we are expecting. 2, 4, 5, 7, 8. Yes. So these are the fourth iteration and we are done with 2 stack. Anyone has any doubt here? Yes, we are inserting at bottom only. Yes, we do one less swap. Yes. Logic clear? Let me show you the code also. You guys see. So this is the first. This is the empty stack which we are talking about. The empty stack which has been given to us. And this capital S is the original stack, which is stack 1 in our example, right? And now like you can see, this is the first iteration we are starting, which will be run for I less than n. Means our elements, we have 5 elements here. So this iteration will run 4 times. So 0, 1, 2, 3, 4. This iteration will go for 5 times only, 0 to 5. Okay. But in the fourth iteration, we will get back the result. Now you can see, first we are taking the top element as a temp, which we are taking. Then we are popping it out. And then we are calling a shift element function. We are calling the shift element function. And that shift element function is doing the same thing. All the remaining element, put it into the S2. You can see, I am providing n minus I minus 1. Right now my n is 5, I is 0, and minus 1. So 5 minus 0 minus 1 means 4 elements. Now you can see in the shift element, we are not doing anything. In the shift element, we are just running that loop. 0, 1, 2, 3, 4 times this loop will run. And you can see we are simply popping it out all the remaining element from the stack 1 and then pushing it back into the stack 2. That's what we are doing. And once the stack will be empty, once the stack is empty, we are simply pushing the temp element there. Stack dot push that temp element. And then after the pushing, we are shifting remaining element from S2 to S1. You can see from S2 to S1, from S2 to S1. And that's what we can see here. That's what we are doing here also. From S2 to S1, last step. And then we go for the next iteration to do the same thing. You can see. So that's what happening here in the code as well. You guys can like look into this code. Later on, you guys can try it. It will work in a similar way. Okay, guys. Meanwhile, somebody has one doubt. Let's see that. Hariharan has one doubt. Okay. So stack 1 is there. Stack 2 is there. If stack 1 length is 0, return. Okay. Temp is stack 1. Stack 2 dot push. And reverse stack 1. Hmm. Yeah, it will work, but you are not pushing back in stack 1. You are printing out stack 2. That's not correct. We want stack 1. Okay. Yeah, no problem. Yeah, that code is already pushed. That code is already pushed. I see every code of mine is pushed already. Okay. Now let's jump into the next question. Can we jump into the next question, guys? Anyone has any doubt? Let me know in the chat quickly. Okay. I think the next problem is already we have discussed, I think. Given a stack, find the max and minimum value stored inside it. Have we not done it? Finding out max and minimum? Yeah, please tell Suraj, what is your code doubt? Yes, we did that. What is the doubt in code, Suraj? I have opened it in the screen. Or you want to try it and then we can talk about it later as well. Okay? Yeah, sure. You try. Okay, so I will quickly tell you the logic about it. Max and minimum, how we did it in last class. So I remember if we talk about the same stack here, 8, 5, 1, 9, 2. This is our stack, and we want to find out the max and min. So I remember I first kept my top element as max as min. Max is equal to 8 and min is equal to 5. Sorry, min is equal to 8. I kept both as 8. If you guys remember, both as 8. Then I started popping it out. Then I started popping every element from this stack and then started comparing it. Like first I will pop 8. I will compare. Is it the greater than max? No, it's equal. I will not update my max variable. Is it the lesser than min? No, I will not update my min. Now we'll go for 5. Now we'll go for 5. Is it the greater than max? No, I will not update my max. Is it the lesser than minimum? Yes, I will update my min. I will update my min to 5. Correct? Now again, I will pop the next element, which is 1. Is it greater than my max? No, I will not update my max. Is it lesser than my min? Yes, I will update my min. So now my min will become 1. Now let's pop the next element, which is 9. Is it greater than my max? Yes. If yes, then update it. Is it is it lesser than my min? No. Now let's look for 2. Is it greater than max? No. Is it minimum than min? No. Not updated. That would be our answer. If you guys remember, that's how we did it in our last class or whenever we did it. Right, guys? Same way we did it earlier as well. Yeah. So there is one, there is code as well for max min. If you guys see there, max min, yeah, it's here. You see, I'm taking my top element, then I'm running a loop till our stack is not empty, and then I'm checking it with the top element and doing the pop and updating my max and min, whatever value is coming. Whoever is a max, I'm updating it. That's what I'm doing. And then I'm returning my response at the end. Have you understood now the second question? Yes, we did that. Yeah, sure. Sure, Joseph. Okay, so let's jump into today's problem. I think in today's slides also we have already done 2 or 3 problems, but 2 questions are very interesting. Okay, so first we will start with one interesting question in today's slide. So let me close first the previous one, and now let's jump to the today's one. You guys are able to see my screen, right? Yes, you are, right? Okay. Now let's jump into the first question, which is little bit interesting. Not that much, but little bit. Okay. So the first question is, guys, binary number generation. Binary number generation. I'm sure you guys are already aware of binary numbers, right? All the binary numbers have 2 type of digits, 0, 1. All the decimals numbers can be converted into the binary numbers, and the binary numbers are bits like 0 and 1. And the binary number is the language which mostly computer understands. 0 means off, 1 means on. That's the electricity, how the electricity works. Off means 0, 1 means on. So that's how the binary numbers work. So we need to generate the binary numbers here, and they're saying they will be giving a number n, and your task is to generate binary number having decimal value from 1 to n. Like if they are giving you 3, so you need to generate the binary number for 1 to 3, like 1 to 3. So for number 1, for number 2, for number 3, you need to generate the binary number for them. Like if you remember for the factorial example, they tell you, right, give me the 4 factorial, or if you guys remember the prime number, so like give me the prime number between 1 to 20. Similar way they are saying. So they will be giving you one like digit n5 and one. They have given you one variable n, and you need to find out the binary number from 1 to that number. Okay, everyone understood the question? That there will be one value will be given to you, and you need to find out binary number till that value. So Suraj, they will be giving you like one number to you in a function, and you have to provide a binary number for till that number from 1. Like if they are giving you 10 and the value of n is 10, so you need to now find it out the binary number from which is starting from 1 till 10. So 1, binary number of 1, binary number for 2, binary number for 3, binary number for 4, binary number for 5, binary number of 6, till 10. Everyone understood now the question, what they are asking? That's what they're saying. Binary number generation. Your task is to generate binary numbers having decimal value from 1 to n. Are we good with the question? Everyone, give me thumb here. No need to write yes also. You can give me thumb here. I can understand that. Yes? Okay. So now let's try to create some binary numbers. Let's try to create some binary numbers till 7 or 8 or 9, 10, 10. Till 10 we'll try to create. And we'll see some pattern. Guys, while I will try to create those binary numbers, you guys see some patterns there. Okay, let's start with 1. So see, for 1, the binary number is 1 only, right? Because see, how binary numbers work: 2 key power 0, 2 key power 1, 2 key power 2, 2 key power 3, 2 key power 4, 2 key power 5. If I provide all places 1, 1, 1, this would be all will be added. Correct? That's how the binary number work. So right, for 1, it will be 1 because 2 ki power 0 is equal to 1. I'm sure you guys know how to calculate the binary numbers. Everyone knows about that, right? The binary numbers. Okay. Yeah. So now let's jump into, let's create for 2. And I'm saying you guys also see some pattern here. So for 2, it would be this one. Yeah. So 1 and 0. Right, guys? 0 will be like 1 and 0. So 2 ki power 0 will be, and 2 ki power 1. So 2 ki power 1 multiply by 1 plus 2 ki power 0 multiply by 0. That's how we calculate 2 plus 0 is equal to 2. Right, guys? That's how we calculate the binary numbers. So for 2, it will be 1, 0. Guys, follow pattern here. You will see some pattern here. Okay. Now let's go for 3. What would be for 3, guys? 1. No, 1 will not be there, I think. Yeah, 1 will be there. 1, 1. Yeah, this is 3. Guys, now start seeing pattern. For 4, 1, 0, 0. For 5, 1, 0, 1. For 6, 1, 1, 0. For 7, 1, 1, 1. For 8, oh, guys, I'm doing right? Everyone is able to understand how we are writing 1, 1, 1? Anyone has any doubt with that? First, let me know in the chat. Anyone has doubt with how I'm calculating the binary numbers? You guys can create in your mind also. Okay? Anyone has any doubt? Yes, tell me your doubt, Suraj. What is your doubt? Yes, Hariharan, please tell me. No idea, calculate binary. So, okay, that's a different question. So, for calculating a binary, the very nice way is you should remember these things. Always binary number, if you want to calculate. See, every number is represented by, I will take some 5 minutes, guys, for explaining you Hariharan and Suraj. And Suraj and Hariharan, you guys can later look into the YouTube as well, how to calculate the binary numbers. And in our revision class, we'll also talk about it. And I will try to explain you quickly also. Okay, so first understand every decimal number, decimal numbers like this. Decimal numbers like 0 to 9. 0 to 9, these are decimal numbers, which are like decimal numbers, like which the numbers which can be calculated or combined with 0 to 9. Those are decimal numbers. Okay. So every number I'm talking, I'm not specifically about decimal, every number can be converted into binary numbers. Okay. And always binary number represented with 1 and 0 only. And Suraj and Hariharan understood these are two things, that every number can be converted into binary numbers, and binary number represented with 1 and 0. Are we good with that? Okay. Now, there are many ways to calculate it, but I quickly remember it with this way. Every number can be calculated with this way. Every number. So see, if I want to, you remember this thing, 2 ki power 0. Okay, 1 minute. Always binary number will be calculated with 2 ki power 0, 2 ki powers. 2 ki power 0, 2 ki power 1, 2 ki power 2, 2 ki power 3, 2 ki power 4. Okay, 2 ki power 0 is 1, 2 ki power 1, 2, 4, 8, 16. Right? You understood these things? Hariharan and Suraj, quickly respond me this thing. Understood this thing? Now, if I want to generate like binary number for 1, so it would be simple 1. Wherever I am keeping 1, that will always be considered with the 2 ki power 0. That will always be considered with 2 ki power 0. So now you can see 2 ki power 0 is equal to 1. That's what. Let's go for 2. 2. So 2 would be 2 ki power 1 here, 0 and 1. Wherever I am keeping 1, that would be considered as, that would be used as a value. That will be used as a value. Okay, one more thing you can understand, like this. 2 की power 0 multiply by 1. 2 की power 0 multiply by 1. Here also you can understand. 2 की power 1 multiply by 1 plus 2 की power 0 multiply by 0. So upper number will be multiply with these. Like how many digits you are going, you will be using these 2 की power zeros only. So let's go for 3 also. 3. So 2 की power 1, 2 की power 0. But you will keep it here 1, 1. So now you see some pattern here. So 1, 2 की power 1 multiply by 1 plus 2 की power 0 multiply by 1 will give you 2 plus 1 is equal to 3. Okay, let's go for 4. Again, same pattern. You have to start like this: 2 की power 0, 2 की power 1. Okay, now if you are giving 1, 1, you will only get 3 here. You will only get 3. But now again keep one more 1 here. Keep one more 1. So once you will keep one more 1 here, you have to keep 2 की power 2 here. You can see 0, 1, 2. So now again do the same calculation. Will it work? 2 की power 2 multiply by 1, 2 की power 1 multiply by 1 plus 2 की power 0 multiply by 1. Let's do the calculation. 4 plus 2 plus 1. It will give us 7, not 4. We were looking for 4, but we are not getting 7. You guys tell me what we need to do here. How can get the 4 with this value? And we can only represent a binary number with 1 and 0. So you guys tell me, Hariharan and Suraj, what should we do? No, yes, the 1, 0, 0. So Joseph, you should not tell. I'm only talking to Hariharan, right? So yes, that's right. So we are going to do 1, 0, 0 here. Yeah. So now you will see. Now you do the calculation. 2 की power 2 multiply by 1 plus 2 की power 1 multiply by 0 plus 2 की power 0 multiply by 0. You will see only 4. Everywhere you will get. Here you will get 0. Here you will get 0. You will only get 4. That's how I am doing this calculation also, guys. If I want to calculate for 5, I will again do the same thing. I will start with 2 power 0, 2 power 1, 2 power 2. Because already I have covered this much. I have to go, I can only get the answer here. So now this will be this 1001, 101. Because this first digit always giving 1 to us. Second digit always giving 2 to us. This third digit always giving 4 to us. Whatever way you want to remember it. So you can see 1, this one will only come. Now I hope you understood. Now for 6, it will be 1, 1, 0. 2 की power 2, 2 की power 1, 2 की power 0. And for 7, we have already seen 1, 1, 1. Suraj and Hariharan got some idea about the binary numbers, how we are calculating? Good. So that's how we are calculating the binary numbers. So till 7 we have calculated. You guys tell me for 8. Suraj and Hariharan, only Suraj and Hariharan will tell me about the 8. You guys calculate it quickly and tell me what would be the binary number for 8. Suraj and Hariharan only. Tell me about 8. How many? 1, I will keep it here. So 1, 0, 0, correct. 1, 0, 0, 0. So 2 की power 3 will be here. Yes. Or for 9, 1, 0, 0, 1. For 10, 1, 0, 8 and 2. Yeah, 1, 0, 1, 0. For 11, it would be 1, 0, 1, 1. For 12, I believe 8 and 4. Yeah, 1, 1, 0, 0. Right? That's how we'll work. That's how everyone understood now how we are calculating these numbers. Anyone has any doubt? Let me know right now, right away. Yeah, we are good. Now, guys, I will show you one pattern here. Okay. Now you guys see that I'm again writing the same binary numbers again. And I will show you one pattern here. Okay. Anyone observe any pattern here? First, tell me any one of you have observed any pattern here? Quickly tell me. If no, then no need to. They are ascending. Okay. So yes, that's true because they're ascending what? If you're saying they are incrementing, yes, because the size, as the number is increasing, definitely the size will increase of 1 and 0. Increase, yeah, that's fine. That because number is increasing, right? 0. Incrementing in 1 and 0. Incrementing in 1. Yes, I think Arad has got the logic here. So yes, that's totally true, guys. You guys have, I'm not sure you guys have observed it not. So we started with only one here. Then what we did, we have incremented 1 0 here, 1 1 here. You can see these are the incremented numbers, 0 and 1. In the same one, in this one, we have added 0 and 1. We have added 0 and 1. Now you see, I'm not seeing above number. Now in this 1 0, we are going to do the same thing. We are again going to add 0 and then we are going to add 1 in the same 1 0 in this whole number. Again, you see, in 1 1, we are going to do the same thing. 1 1 0, 1 1 1. Again, you guys see, take this number 1 0 0 0 1 0 0 1. Take this number now 1 0 1 0 1 0 1 1. You do not need to see above. Just go like this 1 1 0 1 1 0 0 1 1 0 0 1. Now go for this 1 1 1 0 1 1 1. Guys, you do not need to see above. You can see there we are just starting from 1 and we are just simply adding 0 comma 1 0 comma 1. Then we are just simply adding 0 comma 1 in always on the top element. Whatever element is in the top or in the front, we are just taking that number and adding 0 and 1 into that. 0 and 1 into that. 0 and 1. Can you guys see that pattern? Now can you guys see that pattern when I told you? Everyone, tell me, can you guys see that pattern? Suraj and Hariharan might be thinking why I explain that much about this. I could simply tell this. They have to just simply extend 0 and 1 to get the binary numbers. But this is just a trick. But if somebody is asking you to directly get 84, you will not start doing these things, right? Yeah. Yeah. So now, guys, everyone understood this, right? So now you tell me which data structure is going to be perfect here, because we need to insert the number from back and always take the number from front. For adding 0 and 1, we need to take the number from front, and every time whatever new number we are creating, we need to add it from the back. Which data structure is best here? Q. Totally right. So in the Q, we are going to start with Q only, guys. So we will take one empty Q here and we'll put 1 there. And then we'll start our loop. So from 1 to n, like if the n value is 5, so we'll start 1 to 5 loop. And less than 5, I would say. And then we'll again in the Q, we'll first push 1 here, then we'll go inside that, take this element out and add 0, push it back 1 0, add 1 1, push it back 1 1. Then take again this element 1 0, add 0 into that, push it here, then add 1 0 1 also and push it here. Take again the first element, and this will happen till 1 less than 5. And every time when you are taking the element out, print it out. Console.log, print that element 1. First time 1 will be print, second time 1 0 will be printed, 1 1 1 0 0 1 0 1. That's what the 5 element we need to print, and that's what you can see in the output also. 1 comma 1 0 1 1 1 0 0 1 0 1. Understood, guys? I will also show you code. Very easy code. Very easy code. Yes, you can see I have taken one empty Q. I first pushed 1 there. Then I am putting my loop n minus minus. It means every time n minus minus. And when n becomes 0, it will stop there. And then you can see here, I am taking my top element, removing it from the queue, printing it out, then adding 0 and 1 into that. S2 and S1, you can see S2 and S1. Like same values. First we are adding 0 because S2 and S1 equal. So we are first adding 0 into that, then we are adding 1 into that. And then we are doing the similar thing till our loop is going to end. Just see this code. Okay? Understood everyone? Are we good with that, guys? Yes, very neat and smooth. Yes. So this was very easy question actually. Okay. Can we go into the next question? Anyone has any question, any doubt? Are we good, guys? Can we go into the next question? Let me know in the chat. Joseph says yes. What about you? Arad, Nayan, can you run the code? Okay, so Arad wants me to run the code. So let's run it. So node Q, this is the Q folder, right? Yes. Q slash binary or this. Here are 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. Okay. Yeah, Parag, code is open here. Any doubt here? Everything good, Parag? Already done. We already done, right, dry run? You want me to do it again? No problem. I'll do it again. So see, first we have pushed the first element 1 because we know that we have to start from 1. So we have pushed it here in our queue. Then we are shifting it out, taking it out that element, printing it out. Then we have taken one variable where S2 is equal to S1 just for like two different variables for like reference perspective. We can go with same variable also S1. Then we are adding S1 plus this. You can see we are adding also. So that's why taking S2 is good. So S1 we are adding S1 in the same 1 we are adding 0. In the same 1 we are adding 1. So 1 0 1 1 both will be pushed into the queue. Now again second iteration will run and this n minus 1 n will only stop when we will get the 0 here. And then our loop will stop. Same thing, right? We started with 1, then we pushed 1 0, then 1 1, then 1 0 0, then 1. Why you shift? Shift for removing the first element. In the slide, you see, we are removing these elements from here. We no longer need these elements. Whatever element we have printed it out, we no longer need those elements in the queues. How loop is terminating? Because loop we are subtracting, right? You see, n minus minus. So first n is 5, then 4, then 3, then 2, then 1, then 0. In 0 it will stop. We are doing n minus minus, right, Tarat? So n minus minus means n minus 1. N minus 1, it will automatically subtract it. Yes, yes. Won't it go because we are not checking? So when while will become 0, it will not go, right? When n will become 0, Arad, it will not go inside it. We are printing values using console, not printing queues, right? Yes, we are simply printing the values with the console. Yes, it will. Yes, definitely. Definitely, Parag. While and if, both will stop there. Okay? In the while loop or in the if loop, if you are passing 0, it will not go inside it. Okay? Understood, Parag and Arad? You both have same question, I think. Yes, 0 is false. That's why it will not go inside it. Okay. Can we jump into now next question? Do you guys have any other queries? Got it? Okay. So now let's jump into the next question. I think this question we have already done. Queue using stack. Queue using stack. Do you guys remember? Queue using stack, stack using queue. We have done this program, right? I will just quickly explain it and then we'll jump into the next question. Or you guys know about it. You don't want me to explain it. Yes, with the two stack. You guys want me to explain it or not? No need. I do. We already did. Okay, no need. Then we can. Everyone agree with that? I can. If you want, I can quickly explain the logic only. No need to go into the that part, the coding part. Like, you want me to explain it or explain the logic, or can I jump into the next question? Okay, let me explain the logic quickly. Okay. So queue using stack. So you guys remember that this is our queue. In queue, all the elements goes out from the front and we insert it from the rear, right? And they are saying we need to implement this queue with the help of a stack. And if you know that in a stack, the first element, whatever we insert, it go into the bottom, and then we put it all these things. Whatever the last element will be, whatever the last element, that will go out first. That element will go out first. But in the case of queue, in the case of queue, whatever the first element is, that element will go out first. But in the stack, whatever the first element is, that will go at the end. Everyone knows that. Everyone know that, right? Now we want to implement this queue with the help of a stack. So what we'll do, we'll take two stack here. We'll take two stack here, S1 and S2. And let's run it with some example. So like 2, we want to insert 2, 4, 5, 6, and 7. Okay. And Q has two operations, NQ and DQ. Correct? In NQ we insert it, in DQ we delete it. So now we do not have Q, but we want the feature of Qs. And with the help of a stack. So we have these two stacks now, and we want the feature of these two. So if I do NQ, NQ2, NQ2, this should be inserted like Q in these two stacks, right? And if I do DQ2, DQ simply, DQ, then I should be getting 2 here, not any other element. Okay, that's what we want. So what we'll do, guys, this is our S1, this is our S2. So we can like make any one of operation constant time. We can make DQ also constant, or we can make NQ as a constant. One of the place we need to iterate it. So what we are going to do in NQ, we are going to do that. So while we are inserting any element, we will always insert it into the top. That inserted element should always come to the top. So whenever we are deleting it, so we can easily delete it. Correct? So like if you know that in a stack, if we are going to insert these elements, so it will look like this: 2, 4, 5, 6, 7, right? And then when we will do a DQ, 7 will be written here. But we don't want that. We want 2 to be written back. Correct? So that's what we are going to do while NQing. While NQing, while inserting item, we are going to take care of that. Whatever we have inserted whatever we inserted first, that has to always be in the top. Whatever next element we are inserting, that element has to go into the bottom. So now for that, what we need to do, this is our S1, this is our S2. So first time we inserted 2, okay, keep it here because the stack is empty right now. So this is the first element. If we'll do DQ, we'll get only 2. But now, once we inserted NQ4, now we need to do the operation in NQ. So what we will do, before inserting this element, take all the elements out of this stack. Take all the elements out of this stack and move it back to this one. Okay, move it back to this one. So 2 will be coming here, correct? And after making this stack empty, insert this new element. Insert 4 in this place. And once this element is inserted, keep back all of the elements from here to, from stack 2 to this one. From stack 2 to stack 1. So now here 2 will be coming at this place. Now NQ6. Do the same thing again in NQ6. Take all of these elements here back 2, 4, insert 6, and then take out all the elements from here again 4 and 2. And when you will do DQ, when you will do DQ first time, you will get 2, again 4, again 6. Guys, is it now working as a queue or not? With the help of 2 stack, working as a queue only, right? NQ and DQ operation, we have achieved it. Understood, Hariharan? So that was the logic here. We have to take the 2 stack. And every time if new element is coming, we need to first pop it out every element in the stack 2, and then insert the new element. And after inserting, bring them back. Understood, Hariharan? And we have the code also, Hariharan, or for others as well. We have the code for that, right? We have already implemented queue using stack or stack using queue. So you can see here the code. First we have, you can see, if S1 has any element, take it out, push it into S2. Then push the new element, then bring back all the element from S1, from S2 to S1. And in DQ, you can see it's the constant time operation. And we have similar stack using queue also. Okay, so now can we move into the next question now? Okay, let's move into the next question. Yeah, this one would be little bit different. Till now we have implemented queue using stack queue using arrays, right? We have implemented queue using stack using arrays, right? Now we will implement queue using linked list also. Queue using linked list also. That's also very easy. I will show you with the visualization. We can implement queue using linked list also, right? I already told you earlier. We can implement queue using arrays or linked list. Every time we have seen with the arrays now we'll see one example with linked list also. Okay. So now let's see that very quickly. We already know, just discussed it. In queue, we have front, from where we delete element. We have rear, from where insert element, insert and delete. Everyone knows that. And just now we discussed it. Everyone knows that, right? Correct. And now if I talk about the single linked list, in single linked list we have start and then we have end. So whenever we will insert element, we will add it at the end position, and whenever we want to delete something, we'll delete from the front position. So did you guys already visualize the code? I'm sure like you guys have already visualized the code also. Yeah, that's why push and pop and NQ and DQ operations are constant type operation, because if you use the linked list on the back end, these operations are not going to take n of anything. Let me now write the code as well. So now we can say that when we can take 2 pointers, start, or we can say, man, we can only take front and rear only. These are now the pointers, front and rear. This front is start, I'm again telling you, of the linked list, and this rear is end of linked list. Okay, now our linked list is empty. So now start and end both are front and rear. I will say them front and rear. So now front and rear are pointing to same null position. Correct? You know that, right? In the linked list we have already discussed. When our linked list is empty, front and end both are pointing to null. Now Q is also empty, so front and end both are pointing to null. Now add a new element. So for adding a new element, we'll create a new node. So that would be 5. Correct? We'll be creating a 5. And this will have 2 things. One data, second address. So now, because this is the first element, both will be pointing out to this. So now 5 will be here. Front will also pointing out to this, and rear will also pointing out to this. Right, guys? You know that this will be the happen for the first scenario. Correct. Now we'll do the NQ of 6. Now next element. So again, new node 6, and this will be added at the rear position only, at the back side or at the end side. So now 5 will be added here to 6, and 6 will be pointing out to null. And this will be our rear now. We will update rear to there. Front is still here. You know that, right? We already done this. NQ7, add it only at the last. So 5, front is here, 6, 7, and this is our rear. And now if you want to do DQ, we'll do it from the front. We'll delete from the front. So now 6, 7, rear will still there, null will be here, and now front will become 6. That's all, guys. NQ and DQ linked list. Was it difficult? Yes, rear is still. Yes, 6 become head now. Yes, 6 is head. Front and rear are head and tail. Yes, let me show you the code now quickly. Q using linked list, yeah. You see, 2 pointers, front and rear. This is our linked list node or Q node, because we are creating Q with the help of linked list. Here I'm taking key. Data is a key here, right? In the example, you guys have seen data here, right? This 5, which is key here. Okay. Now you can see in the NQ operation, I'm creating a new node. If my rear is null, it means front and rear would be at the same position. So you can see front is equal to rear is equal to temp. First element. Now, if rear is not null, it means rear already has any element. So rear dot next is equal to temp, and rear is equal to temp. Right, guys? So rear dot next is equal to temp, new element, and rear is equal to temp, new element. New element will become new rear. Same for front. If front is equal to null, simply return it, because we can't delete anything. And then front is equal to front dot next. And if front is null, the rear also, make the rear also null, because this is the last scenario will happen only for when we have one element. Like if we have only one element, 5, front is also there and rear is also there. Now if you want to delete it, so now there will not be anything in the front. So front will become to null and will also make rear to null, because this 5 has been deleted. So that's why this line is written here. Front is, after doing this operation, front is equal to front dot next. If that's the case, if now front is becoming null, I have to make my rear also null. Yes, definitely it's easier than a stack using Q and vice versa. Everyone understood now? Coding is also not difficult. Clean codes. This temp could be null also. After this line, we can write temp is equal to null also. That particular node will become deleted or become null. Will not keep any data. Understood, everyone? Can we move into the next question now? These are very easy questions actually. We can go for break after this question, Suraj, because next question also we have already discussed. So I will just discuss the logic about it. But before that, has anyone has any doubt in this one? Because this was very easy. Q using linked list. Everyone good? I'm not making anything in hurry. That's why I just want to wait and ask you guys. Anyone has any questions here? Because I don't think in the revision you guys will have any questions there. Okay, so let's now move into the next question. That question is also we have done it. Reverse first k element from Q. Guys, have we not done this question also? Reverse first k element from Q. We have done this, right? What was the logic for it? I will quickly discuss the logic so you guys can remember it. It was very easy, right? Yes, with the help of a stack, we did it. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total length is 9, right? Total length of array is 9. This is our array. And they have given k as 5. So we have to reverse these first 5 element. We have to reverse this first 5 element. So these 5 element we have to reverse it. So our output will look like this: 5, 1, 5, 4, 3, 2, 1, 6, 7, 8, 9. Correct, guys? Yes, that's how we looked up. So what we did, if you guys remember, we have taken one stack here. Correct? And then we did the iteration on this array and pushed all these 5 elements into this stack. So 1, 2, 3, 4, and 5. We pushed it like this. That was stack Q. Yeah, it was stack only, right? Yeah. Correct, guys? We have pushed it like this. And after that, once we pushed it all 5 element, now our final array will look like this: 6, 7, 8, 9. This array will look like this, right? Everyone agree with that? Our array will look like this. Correct. Now what we did, we iterated the second loop and we again pushed back all this element into this stack, in this array. Again pushed back this element in this and from the top. So now our array will look like this: 6, 7, 8, 9, 5, 4, 3, 2, 1. Correct. Again we pushed back into original array. And now after this, we have calculated the array length minus k. Array length minus k. Array length is 9 and k is 5. So 4 element. So we'll delete these shift. This is q. So we'll shift these 4 element and insert them back into the array. Insert them back into the array. That's what we did. 5, 4, 3, 2, 1, 6, 7, 8, 9. And that was our final output. Correct. That's what we did. We have run 3 iterations. Question is to do use. Yes, we are using the queues on queue also. We are also using the queues operations. And we are also using the stack to achieve it. Understood, Joseph? We are using both things here. Stack and queues both. Can't we use unshift? Yes, we can do that as well. We can do that as well. It would be easy, like, yeah, like if you want to go with the unshift, we can do that as well. We can go with that solution also. Yes, Q. Understood, Joseph, your question. We are shifting it, right? These elements, 6, 7, 8, 9, we are taking it out and then pushing them back. So this is Q, right? We can only take these elements in the Qs. We can only take 6, 7, 8, 9 from the front side with the help of Qs only. Yes. We already have, I think, this code. Remove reverse Q first K element. Yeah, reverse Q first K element. You say here? We have taken one stack empty. Then we have pushed all the element in the stack, deleted from the queues. Then we are again pushing them back into the queue. And then at the end, queue length minus k, deleting in and then putting in them back. Already completed this question, right? Earlier as well. So now we can go for break, and then we can come back for this beautiful question, which is circular tour. Very interesting question, guys. Circular tour. I'm, by the way, this question is not related to Q, but people have solved it with the Q also. But I will solve this question without the use of Q also. Without the use of Q. I'm not sure why they put it this question here, but yes, some people have solved this question with the help of Q also. But I will show you the way that we will not solve this question with Q. But that is very interesting question. I will explain you after break. Have you ever tried implementation quick sort with linked list? Just asking us tried out but not failed. Quick sort with linked list means you were trying to do sorting in linked list. That's what you mean? Like you have one linked list and you were trying to do the sorting on that and you were trying with quick sort. I have not tried it, but mm, do we need it quick sort there? Because uh, we have tried it, right? We have tried, I think in linked list, we have tried some questions, right? Where we did the sorting of our linked list or not. We have reversed the linked list, I remember. Anyone remember? No, no, there would be question. I'm sure there would be question. But I'm just okay. So the question is specifically that you need to do the sorting with quick sort in linked list. Okay, okay. I have not tried it. I can try that. You can share me that question. I could look for it. Yeah. Okay, guys. So we can go for a break now, and then we can come back for this interesting question. Okay. So right now it's 9:30. So let's come back at 9:45. Okay, everyone. Come back at 9:45. Can you guys see me and hear me? Is everyone back now? I know today actually I am 1 minute late. I'm sure everyone is back. Yeah. Thank you. So let me share my screen and let's jump into the next question, which is little interesting. So now guys, what they are saying, question is little bit twisted, but yeah, let's read it. We have given a circle where many petrol pumps are installed. Okay, so there is one circle. In that circle, many petrol pumps they have installed it. Now they're saying also the amount of petrol at each petrol pump and the distance between them is given. So there will be one array given to you, and in that array, the elements are representing amount of petrol at each petrol pump and the distance between one petrol pump to another petrol pump is given. Okay, so just read it. I will explain it again with little bit more context. Your task is to find the first point in circle where a truck can complete its first circle. I know a little bit twisted, but just understand. We need to find the first point in that circle where a truck can complete its first circle. Okay. We have to assume that the truck can cover 1 unit of distance with 1 liter of petrol. Okay. Now they have given us this data. Let's take this data. I know you guys have not understood question. I know that. 4 comma 6, 6 comma 5, 7 comma 3, and 4 comma 5. Okay. So first second line is telling us about this data. So the first point of here is the amount of petrol in petrol pump. Try to understand one by one everything at petrol pump. So we can say here there are 4 petrol pump: 1, 2, 3, and 4. Right? Right, guys? There are 4 petrol pump, and now in the 4 petrol pump they have given us 2 values in each petrol pump. This is the amount of petrol this petrol pump 1 has. This is the 6 liter. We can say this is 6 liter petrol which petrol 2 has. There is 7 liter petrol which petrol 3 has. There are 4 liter petrol which petrol 4 has. Now the second value here is the distance between this petrol pump to next petrol pump to next petrol pump. Okay, so now 6 is the distance between P1 to P2. 5 is this 5 is distance between P2 to P3. So 6 is distance between P1 and P2. Okay, then we have 5. 5 is distance between P2 and P3. Same goes for 3. 3 is distance between P3 and P4. Same goes for 5 again, this 5. Right? Now we're talking about this 5. This is again distance between P4 and P1. Because they are in circle, right? They are in circle. Okay, tell me in the chat, did you guys understood till now? Did you guys understood till now? These values, what these values are representing? Did you guys understood? Anyone has any doubt? For P4, yeah. For P4, distance is given, the second value is given as a distance between P4 to P1, and the petrol is 4 liter there in P4. The distance is given 5 between P4 and P1. Understood, Arat? The distance is given as 5 there. Oh yes, these all petrol pump are in one circle. These all petrol pump are in circle. So that's why the distance of P4, whatever the value they have given in the P4, that would be distance between P4 and P1. Everyone understood now? Let me know in the chat. Joseph, first understand what I'm trying to explain here. The values. I have not explained the whole question till now. I have not explained the question again till now. I'm just explaining you the values which are given in the question. Did you understood that part? The values which are given in the question? Joseph, did you understood the values which are given in the question? Repeat. So there are 4 points given to us, 4 petrol pumps, P1, P2, P3, P4. The first value is representing amount of petrol at that petrol pump. And the second value is representing distance between this petrol pump to next petrol pump. So now you can understand this 4 is the petrol pump amount of petrol at this petrol pump, at the P1 petrol pump. 6 is the distance between petrol pump 1 and petrol pump 2. Now if I go to this point, if I come to this petrol pump, so now the first value here is representing the amount of petrol this petrol pump has, and the 5 is the distance between this petrol pump to next petrol pump. Same goes here and here. Understood now, Joseph? Okay, everyone understood it now? Can we move into the next part of question? Okay, so now what we need to find it out, guys. We need to start from any one of the petrol pumps. We need to start from any one of the petrol pump, and we need to identify that can we take whole circle of it and come back to same point or not. We just need to tell here, can we take one circle of all the petrol pump and come back to the same petrol pump or not, with the petrol which we has and the distance which we need to cover. So we can say that we have one truck which does not have any petrol. We have one truck which does not have any petrol. So we have to find it out if that truck is standing on P1 petrol pump or P2 petrol pump or P3 petrol pump or P4 petrol pump, any one of these petrol pump. That empty truck is empty petrol truck. If it is standing, can he take whole circle or not and come back to the same point? If that truck is standing at P3, can he take whole circle and come back to P3 or not? That's what we need to find it out. We need to use the petrol from the petrol pump, then we have to cover the distance, and then we need to come back to same position. And once we are coming at the same position, we need to tell to the answer what is the first position from where we will start. What is the first position from where we will start, and we'll cover the whole distance. We'll cover the whole circle and come back to the same position. Guys, understood the question? Understood the question? So guys, there are 4 petrol pumps. And you have one truck which does not have any petrol there. So you need to start from any one of those petrol pumps and take a whole circle, cover whole distance, and come back to the same petrol pump. So that's what you need to do here. and you need to find out that first petrol pump, from where you will start, that I am able to cover whole distance if I am going to start from this petrol pump. If I'm going to start from this, if I started with, see, if I started with P1, but somehow when I reach to P3, I do not have any petrol. I do not have any petrol to cover further distance. So I will say that P1 is not my answer, because if I'm starting my journey from P1, I'm not able to reach P1 again. So I will say that P1 is not my answer. I will now move to P2. I will start my journey from P2. I will take the petrol from the petrol pump, cover the distance. I will again take the petrol from P3, again cover the distance. Again we'll take from the P4. Again we'll go back to P1. Again we'll go back to P2. And if I am reaching to P2 and I have not stopped anywhere, it means P2 is my answer, because that's the first petrol pump from where I started my journey and I'm coming back to P2. Now understood everyone? I'm sure this makes little bit clear this question. So we have, this is the whole question actually. Joseph, this was the whole question actually. We have to now start from any one of the petrol pump, and we need to come back from there, come back to that position only, come back to that petrol pump only. Or whatever the first petrol pump is, that where we have covered whole distance, that would be our answer. Okay, so let's traverse it. Let's start from this question only. Okay, so now I'm starting from P1. Okay, and I'm taking two variables here, guys. Extra fuel and second value is required fuel. I think something has happened with my marker. These are just two variables I'm taking. Okay, so let's start from P1, guys. Let's start from P1. So in P1, my petrol is 4, right? You can see my petrol is 4, right? And I have to cover how much distance? 6. Can we cover it? Can we cover it? From P1, I want to go to P2. I can't cover it because my petrol is 4 liter only. I have 4 liter and I have to cover 6 kilometer. I can't. So P1 is definitely not my answer, because I can't reach to P2 only. How can I come back to P1? How can I come back to P1? I'm not able to go to P2. How can I complete the circle? So right, so P1 is definitely not our answer. Okay, so let's start from P2 now. We'll use these variable later, but let's start from P2. So now in P2, we have 6 liter of petrol and we have to cover how much distance? 5 kilometer. Right, guys? We have 6 liter of petrol and we have to cover only 5 kilometer. We can travel, right? We can travel, we can go. Okay. So what is the extra fuel we have? What is the extra fuel we have? 1 liter, right? Okay. So we'll keep that extra fuel at this place. We'll keep it in extra fuel variable. So now we have covered P2. So now we are starting from P2. Now we'll go. Now we have reached to P3. Now we have reached to P3 with 1 extra liter petrol. Correct? With 1 extra liter petrol. Everyone agree? We have reached to P3 and with 1 extra liter petrol. Okay, now let's see in the P3. So in P3, we have 7 liter petrol and we have to cover only 3 kilometer. So we can do it. We can do it, right? Because 1 extra liter we already has, and 8 liter, 7 liter also we got. So total 8 liter petrol we have, and we have to cover only 3 kilometer. Total 8 liter petrol we have, and we only have to cover 3 kilometers. So how much extra we has? How much extra we has petrol now? 5. So we'll update our extra fuel to 5 now. Now we have reached to P3 also, of P4, sorry. So now in P4, we have 4 liter of petrol. In this petrol pump, we have 4 liter of petrol. So, and an extra fuel, we have 5 liter. So how much total petrol we have? In this petrol pump, we have 4 liter petrol and we already has extra fuel. So 5, 4, 9. So 9 liter of petrol we have right now. 9 liter of petrol we have. And how much distance we need to cover? We need to cover only 5 kilometer. We need to cover only 5 kilometer. So how much remaining, how much extra fuel you have now while we reach to P1? 4 liter, right? So 9 minus 5 is equal to 4. So now extra fuel which we have is 4 liter. 1 minute, guys. You can refresh it. You let me refresh it. Okay, 1 minute. Let me refresh it. Can you guys see and hear me now? Yes. So let me share my screen again. अभी नहीं. Okay. Now better, yeah. So now, while we are at the P4, you can see how much extra we has. 1 minute. I think 1 minute. So here we have 1 liter extra. Here we have 4 liter extra, right? So 4 plus 1, 4 plus 1, 5. Yeah. So while we reach P4, we have 5 liter extra. Correct? Correct, guys? And then we will add P4 petrol pump, P4 petrol as well. So will total will become 5 plus 4, 9. Right, guys? Understood, Suraj? Understood, Suraj? We got the extra fuel as, right? Not extra fuel, total fuel. Total fuel as a 9 liter. Total fuel as a 9 liter while we are at the P4. Correct? Total fuel as a 9 liter. Now we have covered, now we are going to cover this distance. So now we are going to P1. So once we reach P1, we were having total petrol as a 9 liter. Now how much we have consumed it? 5 liter. So now remaining is 4 liter. Or extra fuel is 4 liter. Right, guys? While we have traveled and reached to P1, so the extra fuel which we have 4 liter. Right? Now again you guys see it at the P1 we got more 4 liter. So the total fuel become 8 liter. Total fuel become 8 liter. And how much distance we need to cover? 6 meter. So now we will go from P1 to P2 as well. And once we will reach to P2, how much extra fuel we have? 2 liter. Right, guys? Right, guys? So once we reach to P2, so that's what we need to find out. We started from P2 and we are now come back to P2 only. So now P2 is our answer. In this example, P2 is our example. P2 is our answer. Yes. So if you see here in the slide, you can see second one is our answer, 6,5. This one is our answer. Because that was the petrol pump. If we will start from there, we will reach back to that place only. Everyone understood the logic, how it is working? Anyone has any doubt? Crystal clear? Can't we get for third pair? Can't we get for third pair? But no, our question is not that. From where we are starting, if we are reaching to that place, that would be our answer. We can reach to third pair, but we do not want to find it out. We only want to find out the first one. We can start from P3 as well, but we will start from P3 only when we were not able to reach from P2. When we were not able to reach from P2, then we will only go into the P3 scenario. Otherwise, we will not go. Okay, guys. So let's now think about, let's see if there are many more examples here or not. Otherwise, we have very nice question here. In the this question has been asked in Amazon as well. Okay, and this question is known as gas station problem. You can see my screen, right? There are n gas station along a circular route where the amount, same question. But here what they did, rather than providing the pair, they're providing gas separately and cost separately. They're providing both things separate. Right? And then they are telling, and if there are any scenarios where we are not able to find it out, like start our journey from any petrol, or we are not able to reach any other like same petrol again, we have to return -1. Okay, so let's look for this scenario also. 2 3 4 3 4 3. Okay, guys, let's look for one negative scenario as well. So our gas is, it's working very slow for me. I don't know why. 2 3 4 and cost or distance, whatever you want to say. This is the distance only from one petrol pump to another, which was 343, which is 343. 3 4 and 3. Okay, now let's see this one. We'll again to take the same variable, extra fuel and required fuel. Okay, so now let's start from, this is the P1, this is the P2, and this is the P3. Correct? Now how we calculate the remaining fuel or extra fuel? Extra fuel, how we calculate? Petrol price or gas minus cost. Correct? That's how we are calculating, guys. How much extra fuel we have minus the distance. Correct? That's how we are calculating. But here we have taken the gas and cost. That's just a different name. Okay. So now for the P1, it would be 2 minus 3. Right? 2 minus 3. 2 minus 3. And now we'll take one more variable here, start. Right now we are starting from 0. Right? We are starting from 0. Like the first petrol pump we are checking here. First petrol pump we are checking here. So now we can say 2 minus 3 extra fuel is, this is not going to be extra fuel because we cannot travel this thing. We cannot go to the next one because we are getting -1 here. So this value we cannot travel further. Right, guys? We cannot start from P1. We can't travel. So we have to move to P2 now. We have to move to P2. But before moving, what we'll do, whenever we are getting our extra fuel as a negative, what we'll do, we'll keep our extra fuel in required fuel and make our extra fuel to 0. Make our extra fuel to 0. We'll do every time these. we will do three things. Whenever we are getting extra fuel as a negative, we'll increase first our start, because now our start has to happen from 1. Now we'll start from 1, and we'll keep the negative value in required fuel variable, and extra fuel as 0. Extra fuel as 0. Now our start is 1. So now let's look for P2. This was for P1. Now let's look for P2, guys. Same thing. Gas minus cost. So gas is 3, cost is 4. Cost is 4. Right? We can't travel again. Minus 1. We can't travel it again, guys. We can't travel is again. Right? For the second, from P2 also we can't travel. Everyone understanding this thing or not? We can't travel. Now what we need to do? First step, increase start value. Increase the start value. We'll make our start value to 2. And now extra fuel already is at 0. And in required fuel, add this one as well. Add the new value here. So now this minus 1 will become minus 2, because for covering these two distance, we need minus 2 liter petrols, right? In negatives. So that's what I written it here. Now let's look for from the P3. Now let's look from the P3. So from the P3, gas minus cost would be 4 minus 3. We can travel or not this time? We can travel or not? From P3, we can travel or not? Yes, we can. So now we'll keep this one here. We keep this one in extra fuel. We'll just increase extra fuel. When we can travel, we'll just increase our extra fuel. Now let's look back into the P1 again. Now we are in the P1, guys. Correct? So now you can see here in P1, 2 minus 3. Gas minus cost is minus 1. And we already have one extra fuel. So plus 1, 0. Right? So we can travel to P1, right? We can travel to P1, right? With the extra fuel, we can travel to P1. Right? So now we are at the P1 and we do not have any extra fuel here. We do not have any extra fuel here. Correct? Now we have traveled to here. From here to here. Now we are here. From here to here. Yes. Here. We have come back to P2, right? We have now come back to P2. So, but from P2, again we can't travel to P3. 3 minus 4 is equal to minus 1. Right? From P2, we can't go back to P3, right? From P2, we can't go to P3, right? So now you guys can see when we started from P3, we are not able to reach P3. So it means in this scenario, our answer is minus 1. Understood this negative scenario also, guys? In this scenario, our answer is minus 1. Okay? Understood, everyone? Anyone has any doubt? Good. We are good, right? We started from P3. We started from P3 because before P3, everything was negative only. We do not have any extra fuel. In P3 only we have 1 liter extra fuel, right? Okay. So now, guys, I think I have one thing to tell you, that we do not need to traverse again. There is a one way we can stop it after traversing all the elements. We do not need to traverse them back. And that is the extra fuel plus required fuel. If after traversing all the elements, if we are getting extra fuel, plus required fuel greater than or equal to 0, it means we can traverse it from whatever start, from wherever we are starting. After traversing everything, if we are getting extra fuel plus required fuel greater or equal to 0, it means we can travel from that position. We can travel from that position. Let me show you. Let me not go to P1 and P2 here. Let me come back to the original scenario. I'm not going P1 and P2 again. When I was at the P3, I will show you from there only. So when I was at the P3, my required fuel was -2, right? And my extra fuel was 1, right? My required fuel was -2 and my extra fuel was 1. Am I right, guys? Am I right, guys? My required fuel was -2 and my extra fuel was 1. So if you add them, you will get -1, which is extra fuel plus required fuel is less than equal to 0. It means I have to return -1. You can check for any of the scenario. Any of the scenario. Once you got extra fuel plus required fuel as a, after traversing everything, if you got extra fuel plus required fuel greater than equal to 0, you have to stop it there. You have to say that it's the answer is -1 here. Answer is -1 here. Yes. Anyone has any doubt here? We do not need to come back to again traversing them. Joseph, see, first we traversing 2, we automatically understood we cannot start from P1. So definitely 2 will not going to be answer. The first petrol pump is not going to be answered in any way. Same for P2. P2 is not going to be answered in any way, right? Because we can't reach from P1 to P2. We can't reach from P2 to P3. So that's why P1 and P2 is definitely not going to be answered, right? But for P3, once we reach P3, there was some chance. So see, first thing you need to understand, in any of petrol pump, if you are getting your extra fuel as a negative, that is not going to be your answer. That one is not going to be your answer. You have to move further. Everyone agree with that? First constraint, first condition. In any of scenario, your extra fuel become negative. That one is not going to be our answer. Okay. Now let's look for those petrol pump where we are getting extra fuel as positive. So right. So once we are getting extra fuel as a positive, we will check for the next one. We will traverse the whole array. And once we have completed whole traversal, at the end of that, we will just simply check the values of extra fuel and required fuel. If we add those values, and if the output is coming, answer is coming greater than or equal to 0, so whatever the position right now we are, that is going to be our answer. Okay, that is going to be our answer. Let's quickly I already ran this code. Let me show you if I have the, yeah, it's here. You see, so this is my start variable. We have an extra fuel variable. We have required fuel variable. And then I'm starting my loop into gas one, the array of the length of gas. You can see first I'm calculating the extra fuel. I'm also adding it. If it is a +1, I'm also adding it. In the +1 scenarios, I'm simply adding it extra fuel. If my extra fuel is becoming 0, less than 0, you can see I'm making extra fuel as 0, because in that scenario, extra fuel, we do not have any extra fuel. And now you can also see I'm making my start I plus 1. So wherever, in whatever index, like uh, there are 6 elements. In second element, there was some positive scenarios. So now we will move for the second one, third one. Extra fuel was there, like 2 liter extra fuel was there. We moved to petrol pump 3. But somehow after petrol 3, we got some negative number. So now we have to ignore everything back. We have to ignore everything back. We have to start after this index only. What I'm saying, guys, there is P1, there is P2, there is P3, there is P4, there is P5, there is P6. In P2, we got negative. So we will start from P3. We'll start from here. Right, guys? Now in P4, everything was good. In P5, somehow we again got negative extra fuel. We again got negative. So now we need to ignore everything this back. We can't start from any of these three, any of these fives. We need to start from here. So that's what I'm doing here in the code also. You can see start is equal to I plus 1. In the required fuel, you know that in the required fuel, I was adding that negative numbers and I'm making extra fuel as a 0. At the end of whole iteration, I'm just checking if my extra fuel plus required fuel is greater than equal to 0, return the start position, otherwise return the -1. And if I submit this thing, you will see it is passing all the test cases. You can check this code. I already had it in our. This question is a little bit interesting. I have this question in somewhere. Yeah, circular tour. I have this question here. I'm not sure this was not related to queues anyhow, but this was very interesting question, by the way. Did you guys understood now? I think code was also very easy. Whatever we did, that's what we did. That's what is here. If you guys want to see it once, just see it. You can see I'm doing gas minus cost, means petrol minus distance. Yeah, it was. Anyone has any doubt? Let me know. This was very interesting question. Actually, this question has been asked in Amazon. Return start. Yes, the position from where we are starting. Right? See, every time we are updating our start, if there is nothing negative, we like start is 0. It means from the first position only. If there is any negative, if there is no negative, it means it's the 0th position. And if there are any positions where we got the negative, we'll go for the next one. Next of petrol pump. And we'll take that as a start position. Got it? Yes. It was a good question actually. What about others? Anyone has any doubt? Code will already be in the repo. And if you guys, I will push it into the master also, but the code of queues are in the Q2 branch. But I will push into the master. Let me push into the master in front of you. Let me do that. Or it is in the Q2 as well. Let me do that. 1 minute. Now let me do in the master also. Yeah, it's in the master also. Main branch, master branch also. So everyone understood this thing now? Do we have any doubt here? I have not tried with queues. I'm not sure. I do not have any idea why queue would be needed here. I have not tried with queue actually, because this was the best. We have n complexity, time complexity as n. We do not need any space, extra space here. Space is also constant. This was the best actually we can do for this question. You can see that we have only traversed one time. I don't know why we need extra space q here. That's why I didn't see that solution. When we have the best solution, why would anyone go for the lower solution? Somebody wants to speak. Who is that? Joseph, you want to speak? Oh, okay, that was mistakenly then. Okay, so can we move further, guys? Yes. Let's see what's next is there. I just closed the R tab only. Code name. Code name. What do you mean, Parag? Code name means? I didn't understand your question. You mean the branch name? In meanwhile, let's see what's next. I think we don't have any other question here. Yes, now we have the practice questions, guys. And those questions are totally related to binary tree, which is our next topic. So I think we can now start talking about tree from today's class. Then that might be able, because I told you queue and stack are going to also help you a lot in the trees and graph problems as well. And these two problems which we have next, definitely queue is going to help us lot in these problems. But before that, I think we should be understanding a little bit about the trees. What do you say, guys? Should we start talking about tree from today? You guys tell me. Or from Monday, because according to schedule, we have it on Monday. But I'm thinking we can start talking about it today. Let me know in the chat, and meanwhile, let me give you the code. So it would be in the queue folder. So here you can see that the circular tool is here in the master branch. Yeah. We can do now if nth left. What do you mean nth left? Oh, nothing left. Oh, you guys talk very nicely. Okay, so yes, I think we do not have anything right now. We can start talking about this. That's why, guys, that's why actually I want tomorrow class fully on trees. I don't want tomorrow's class on revision. And after that, I think we can have tomorrow's class on Monday on revision. Yeah. What do you guys say? That's what actually I was thinking. Like we can start today understanding about trees, and in next class also we can talk about trees. And then on Monday, I was thinking like we can talk about other things like the revision part. You guys tell me. I think I can go for the. But yeah, let's. And meanwhile, if you guys make any decision, let me let me know about that. Is it lagging for everyone? Oh, you guys have an exam on Tuesday, Sunday, sorry. Okay, okay. Then I think yeah, revision would be better. Then revision would be better. Hey guys, you guys can tell me in the LinkedIn what question you are looking from all of the things which we had in revision class. I would like just look into those questions again in the LinkedIn. Just let me know what were the questions you guys are looking there. Me to explain it. Okay, sure. Okay. In meanwhile, let's use half an hour. Yeah, please let me know in the chat in that LinkedIn. In meanwhile, let's start talking about trees, guys. Okay. So first, whenever we talk about tree, I think we can easily visualize it, right? From the childhood, we are seeing trees, right? So you guys tell me, what do you guys see in the tree? When you see any tree, what are the things which comes into your mind? I would say that a lot of branches, totally right. Leaves are there, root is there, branches and leaves. Totally right. These are the main things which we see when we see a branch, when we see a tree. Fruits, yes, fruits also, greenery, those all things are there, but those things are not that much related with our terminologies. But yes, there are fruits while we using the trees. Okay, so see guys, I think there are lot of examples, not one or two, lot of places we use trees, right? Like if in general terms, I'm not talking about the the computer systems or anything like that. I'm just simply you guys tell me also the simple like use case where you guys have seen the examples of trees. I think see our family hierarchy, you know, grandparent, then we have parents, then we have child, then we have like grandchild. This is also one tree, right? We call it as a family tree, right? What about tell me other examples of trees. This is one example. Do you guys have? That's why hierarchy is also known. Yes, file system. In our system, what the folder structure which we have, that's also file. That's also tree in one way, right? And if you guys know about the, let's think about some other examples. The family tree is the one tree, and real life trees we have already talked about. Any other example which is coming into your mind? There would be a lot of, no, which are not coming right now. Let's think about choice game. Oh yes, with a game, I remember the chess game. You know, in chess, if we design all the moves of that chess, that could be one tree only. If we just decide the all the moves in the chess, that would also be one tree. It will create one tree. You just try to draw it, you will get one tree only. Atmosphere, Vishal is saying atmosphere. So let's think how he's trying to relate with atmosphere. uh, okay. I was trying to relate it somehow. But there could be some examples. I'm not saying that could be fully wrong. So yeah, guys, so that's what actually tree is. You can see that a lot of places we can use the trees. There would be more examples, but in computer systems, they are using many places like heaps. Heap is there, and hash memories are there, and I think the the arrays also might be in the JavaScript. They have the dynamic, right? They have that. I'm not sure about the arrays will be the perfect example, but yeah, in JavaScript, you know, object in JavaScript, you know that I've told you one time when we were talking about the prototype, when we were talking about the prototype, I told you all the prototype at the end, move to object only. At the end, all points to object. You remember array also points to object, function also points to object, and simple like object at itself point to objects. You remember that thing? Yeah, it's a tree. It's also a tree. Prototype chaining, it's also a tree in JavaScript. So that's what lot of places you will see that they are using trees, because trees provides you multiple way to traverse things. Right now, when we were working with linear data structure, we were doing it on the level wise. We were going into the linear data structure. We were just traversing in one way, correct? You know, in the array or in a stack or in the queues or in the linked list also, we were traversing in one way only, one directional, right? Like, am I right saying anything wrong? You guys understand, right? We are traversing in one way only. Like from 4, we can only go to 5. From 5, we can go to 6. From 6 to 7, one dimensional. Everything happening at one level. But now we are talking about non-linear data structure. The tree is the first non-linear data structure where you can traverse on multiple levels. From 4, you can also traverse to 5, you can also go to 6, you can also go to 7, you can also go to 8. Any multiple levels you can go. That's why it's a non-linear data structure. Let me show you that example also very quickly. See, in this array, you go like this, right? Or in the linked list, same in stack. You always follow one order here, right? You always follow one order here. And then you can first traverse this element, then this, then this, then this. But in tree, this is not the case. In tree, you can go to 5 also, you can go to 6 also, you can go to 7 also. You see, now you are playing at multiple levels. That's what the tree is, guys. Yes, touching every corner of maze, every possibilities. AI and everything's work on the tree only. Every possibilities. Yeah, yeah, that's what I'm saying. When you learn about the trees and graph, you are at the pro level, right? Because tree and graph are the topics which has been asked in Amazon and Google. So if you know about these things, you are at that pro level already. So guys, trees are also very interesting topics. As similar like linked list, you can, because see, trees also uses the same concepts which linked list has. Trees also uses the same concept. In the linked list, we have data and next. Same here. But now you can see it is just not pointing to one. It can point to multiple things. So there could not be only one pointer. You can relate, right, with the linked list. This is one data and it is pointing to multiple nodes, right? Point multiple nodes of point multiple data nodes or point multiple datas. So are you trying to relate it little bit with linked list? Can we relate it? Not I'm saying fully equal to linked list, but little bit, right? Yeah, visualization. Yes, visualization wise, it's little bit equal to linked list. Yes, it points more than one node. Yes, totally. I am expecting for everyone here that after reading trees and graphs, I'm expecting you guys got good fruits, which you all are like doing hard work from, I think, from very long back. Okay, I'm like hoping for everyone all the best, yeah, for that. So let's move further, guys. So what we visualize till now. So first we have seen some of the examples of trees. Like in the real life, we have already seen the trees. Trees has branches, trees has leaves, trees has root. We've already seen these things, right? Now we have also, like technically, we have also seen that what is the non-linear data structure. Why we are saying tree to non-linear data structure? Because it plays on multiple levels. Correct. In linear data structures like stack, queues, linked list, and arrays, we were just playing at one level. But now with these trees, we can play on multiple levels. Correct. Okay. Now let's move further, guys. Now let's move further in the next slide. Till now, are we good? Till now, are we good? And how the tree looks like? This looks like this. See, if you like, I'm not good at drawing, but let me show you how the real tree look like. This is the ground, we can say, and this is our tree. Like, I'm not sure, like you guys can laugh on it, and there would be like multiple leaves, right? Like this, something like this, correct? This could be bad drawing, but yeah, that's how our trees look like in real life. Yes. Yeah. Totally. So that's what our tree look like in real life, right? But in the programs, guys, yes, it's totally weird tree. Fire on tree. Ah. Or trees like right now angry. Looks like ghost. Yeah, some movies we have seen, right? Some movies we have seen that tree is becoming ghost also. Windmill. Better than my drawing. Oh, Suraj has more. You can see that. I still have my drawing is still good. Okay, guys, so let's move. So see, guys, this is our tree, right? In the computer language, you just reverse this tree. In computer language, you just reverse this tree. So see, in the computer language, we can say that. See here. So first understand this tree also. This tree is the root, right? Roots. Every tree has root. Everyone understood, right? Roots. In Hindi we say jad. Every jade we say, right? Jade. So every tree has root, right? So this is the place where we have roots. These are like branches, or you can say, no, say these as the leaves, not the branches. You say these are the leaves. Okay, this could be the branches also, leaves, and then this we can say this is a one branch. Correct? Or let's draw it. Let's draw it. Why not? This is one branch is going, which has these leaves. Okay, so now you can see this is also branch. This could also be branch, right? And this is our leaves. Agree, guys? You have to name them. It's confusing what to say that part. These are like, see, I'm not saying anything new, Vishal. You see the real tree, right? Let me show you. Let me see if I have any diagram here. You see? Okay, 1 minute. Let me open a tree, huh? Real tree. This one is better than mine, okay? Yeah, open this one. You can see this is the root, right? At the bottom. Here we have the roots. Arey, what happened? This is the roots. You can see these are the branches. The middle one is also one of the branch only, right? And then we have these leaves. That's what I'm trying to explain you. Oh, okay. Yeah. So see, guys, the similar terminology we'll use in computer also, in computer language. So, but we start. You can see, we are just like talking about those trees which are below the grounds. You can visualize like that. In the computer language, we are going to talk about those trees which are below the ground. So first we got the root. So this would be our root. Here we will have the root. Then we have the nodes. We say nodes or leaves. This is node 1. This is node 2. Right? This is node 3. Right? And this you can say at branches or edges or links. Anything you can say. This is our branch. This is the leaves or node. Everything here, it's a node. This is also root node. This is called root node. Root means from where we are starting it, right? And this is our nodes, right? And these which are at the last, these also called leaf nodes. The nodes which does not have any child, the nodes which does not have any child, known as leaf nodes. Okay, now guys, we are now started talking about the terminologies, because in trees terminology is very important. Lot of places you will see the questions with these terminologies only. So first terminology which we are using, it's called root node. Okay, and this is our root node. This is our root node which does not have any parents. Root node is that node which does not have any parents, because from that node everything is starting. Everyone understood root node? Everyone understood root node? Okay. Now we will talk about the leaf nodes. Now I'll talk about. Let me also open the diary. I might forget some of the names. That's why I'm just looking at what I need to tell you. Okay. Now we'll talk about the leaf nodes. So leaf nodes are those nodes which does not have any childs. Which does not have any childs. So now you can say in this node, these are the last node which does not have any childs. Now if I create another root, another tree, if I create another tree, like this is a root, this is first, let's give them quickly name. What are the leaf nodes here? Can you guys tell me quickly in the chat? What are the leaf nodes here? Leaf nodes here. Yes, D, E, F, G. If I remove this G, what are the leaf nodes now? What are the leaf nodes now? What are the leaf nodes now? Why we are missing C? Why we are missing C? That's what I want to see, that. Why we are missing C? C is also leaf nodes, right? It does not have any child. Why we are missing C? Parag has missed. Not sure about others. I have not seen the answer. But Parag has missed. Yes. Now, everyone understood now? Everyone now understood? Okay. Now let's see what is the next. Okay, parent node. Sometimes we say parent node. So who is here parent? Can anyone tell me the parent nodes here? Parent node means who has childs. Whoever has child, that node is parent. So can you guys tell me what are the nodes here which are parents? A, B, and root. And root is also parent, right? Nayan, Parag, Joseph, Ekta, A, B, and root. All three are parents because they have childs. Correct? So we understood the parent node now in this question. Yes. Now let's see what is next. Leaf node we understood, root node we understood, siblings node. Siblings node. So guys, siblings are those nodes which are at the same label. You see, they are at the same label. So if I talk about this one, so siblings are A, B, and C, right? Yes, that's also right. That's also right. All the nodes which has same parents. Ekta has also said it correctly. Yes, that make more sense actually. The nodes which has same parent will be called sibling nodes. You can see that A, B, C has same parent as root. So A, B, C are siblings. D and E, totally right. Actually, my earlier definition was totally wrong because F could not be siblings. So yes, D and E are sharing the same parents. Yes, guys, totally wrong. My earlier definition is totally wrong. Ekta's definition is totally correct. So sibling nodes are those nodes who share the same parents, not the same label. Yes, not the same label. Totally wrong, guys. Sorry for that. Not the same label. Same parents. So that's what for DE are siblings because they are sharing the same parents, which is A here. Now, if I talk about the F here, F does not have any siblings. F does not have any siblings. D and E are sibling nodes. A and B and C are sibling nodes because they are sharing the same parents. Understood, guys? Now, sibling nodes. Okay. We have also understood this edge part. This is the edge or link or branch. These terminologies we use. Okay. What is next? A subtree. Subtree. Sometimes people also say subtree. So subtree, you can see this can also be one tree. right guys? This could, see, single element could also be a tree. Single element could also be a tree. Yes, like a subset or subarray. Correct. Totally right. That's what the subtree here. Let me show you the diagram actually which I had here. I think we have already talked about everything, right? Root node, internal node, leaf node, link. Yes, I think we have covered everything here. Okay, what about here? Leaf node we have covered, subtree we have covered, child node we have covered, sibling we have covered, same parents. Now we need to talk about height and depth. Two more things are here which we talk about. Internal nodes are those nodes which are not root, not leaf. Not root, not leaf. Internal nodes, middle nodes. You can see A, B, C are internal nodes which are not root, not leaf. Understood, Suraj? Okay, now let's talk about the depth, and there is squeezed in the between. Yes. Now let's talk about depth and height. That's also a little bit interesting. Depth and height. So for depth, guys, so you just need to understand, for considering the depth, you just think this is your ground. This is your ground. Or let me draw it. No problem. For first, we are going for depth, guys. So this is your ground. Okay. From here, your root is starting. This is your root. And then we have A. Then we have B. Then we have C. Then we have D. Then we have E. Then we have F. Like that. Okay. So, so depth would be the distance from your root to that node, or number of edges between root or that node. If you want to calculate the depth of here, so whatever the number of edges coming between, that would be depth here. You can see for reaching, for root, depth would be 0. For root, depth would be 0. For root, depth would be 0. But now for B, because you can see how many edges are coming for reaching to B. From root, how many edges are coming? Just only 1. So that's why depth for B would be 1. Same for A. How many edges are coming? Only 1. So depth for A would also be 1. I'm writing depth here only. 1. For E, how many edges are coming? 1 and 2. Again 2. How many edges are coming? 1 and 2. Same. 1 and 2. How many edges are coming? 1, 2, 3. So now, if somebody is asking, see why I'm telling you about on the node basis, because sometimes people say that you need to calculate the depth basis on node. So that's how you will calculate the depth for that particular node. Somebody is saying to you, tell me in this tree, what is the depth for E? What is the depth for node E? Then you will tell that it's a 2. If somebody is asking you depth of tree, so you need to, from root, you need to go to the longest leaf node. You have to go to the longest leaf node. That would be the depth of tree. Longest leaf node from root. You can see 1, 2, and 3. So the depth for this tree, depth of tree would be 3 here. So that's how you need to calculate the depth here, guys. That's how first understood it. Then we will calculate also later with the programs as well. Understood about the depth, guys? Understood the depth? Anyone has any doubt on depth? And same goes for tree, guys. Same goes for tree also. But now for tree, same goes for height. So now for height, you need to take it from, you need to start from ground now this time. You need to start from your ground. So now your tree will look like this. This is a root. Like, I think it will work similar, but let's see. A, B, not one. See, some people calculate it like this, some people calculate it different way as well. E and F. So now you can see this is the highest point, right? This is the highest point here. So now height would be 0 here, and we'll go down one by one. This is the height would be 0 here. Some people calculate height from here also. So we'll calculate because this is the highest point, right? This is the highest point. See, we can go from down also. We can go from here also. Here height would be 0, then height would be 1 here, then here would be height 2. So mostly, see guys, for mostly calculating the height also, we also use the same logic. From that node, from that node, go to the longest or farthest, whoever is the farthest leaf node. Farthest leaf node. If I talk about here, if you want to calculate the height for this, if you want to calculate the height for this, we need to go for the farthest leaf node, and the farthest leaf node is only this. So for this node, height would be 1. For this node, height would be 1, guys. Now let's look about this node. You can see they are in the same label. They are at the same label, but you can see for this node, height would be 2, because you can see this is the farthest node, farthest leaf node. That's what the height, guys. And you can, if somebody is talking about height of a tree, somebody is talking about the height of a tree. So from root node, go to the longest farthest node, which would be 1, 2, 3. So for root node, height would be 3, and for height of tree is also 3. But if we talk about any specific node, then you can see at the same label or at the same depth, height are different. Height are different. You can see above, for both places depth was 1, but height is different here. You can see here. You can see height is 1 here and height is 2 here. That's what the one difference I want to show you with height and depth. Did you guys get the difference here between height and depth? Because see, Ekta, for calculating the height for any node, from that node, whatever the longest or largest or farthest, sorry, not largest, farthest leaf node. So from B, the farthest leaf node is at after 2 edges. So that's why height would be 2 for it. For A, the longest or the farthest leaf node is C or D. So that's why it's a 1, only one edge. Understood now, guys? Parag, understood? Yes, I'm talking about height separately. I want to show you the difference between height and depth. So for Parag, for calculating height of any node, from that node, just go for the farthest leaf node. From that node, go for the farthest leaf node. And you can see there, from B, the farthest leaf node is F. So that's what height is 2 here. From A, the farthest leaf node is C and D, which are in the one edge. That's why it's a 1. But for depth, we were not looking that. For depth, we were looking from root to that node. How many edges are there? But for height, we are looking from that node to the longest, farthest leaf node. Longest, farthest leaf node. That's the difference between depth and height. Okay, let's understand with one more example. So this is our root. Okay. Now you tell me height for this node. Tell me height for this node. I will write height and depth both. Tell me height for this node, guys. Yes, everyone understood why it is 2? Because the longest farthest node is this one only. So the height would be 2 here. Tell me the height for this node. Tell me the height for this node, guys. Yes, it would be 0 because there is no node here. There is no edge here. So height would be 0 here. What about this node, guys? What would be the height for this node? 1. Yes, 1. Now let's talk about the depth, guys. You guys tell me the depth for this element. You guys tell me the depth for this element. You guys tell me the depth for this element. Nayan, Joseph, why it's 0? It should be 2. We have to check the depth from root node. So it would be 2. Tell me about this node. Depth. It's again 2. Right. Tell me the depth about this node. 1. Yes. So I hope now you guys have understood height, depth, and all of the terminologies which a tree has. I hope we have understood everything. Child, parent, child node, root node. Yes. Let's see here. There, ancestor node or parent node are same thing. Level is similar to depth. Level and depth are similar. Siblings, you know. Left and terminal nodes, you know. Correct, guys? Anything which is not, which is you do not know here? Okay, we'll talk about the binary tree later. Okay, everything understood now, guys? So you guys tell me now, you guys want to continue this thing tomorrow or you guys want to go for revision? Revision. Okay, so please post all of your queries, post all of your questions in the LinkedIn so I can quickly look into, before coming to tomorrow's session, I can quickly look into those questions. That's fine. That's fine. You guys want to go for revision? That's fine. Because you guys also have tests, right, on Sunday. If you do not have any questions, we will continue this. Okay. If we won't have any questions, we'll continue this thing. Okay, guys. So tomorrow, if we do not have any questions on revisions or any topics or any of the problems, we'll continue this topic today, tomorrow. Okay, guys. So that's all from today. I hope you got little bit excited while talking about trees, trying to understand these. Today, actually, just we talked about the terminologies. In next class or the next to next on Monday, we'll talk the implementation, and you will see that implementation is totally lot of similar to linked list, not fully, but little bit similar to linked list. Yeah, Harian, what is the doubt here? Tell me, I can quickly answer that. The last if condition. Yes, so the last if condition, Hariharan, we are checking that is there like after iterating whole array, we are checking that our extra fuel and required fuel should be 0 or greater than that. If not, then it means there was some petrol pump, there was some scenarios which we can't travel. If anywhere your extra fuel plus required fuel is coming negative, it means we can't travel it at all. We have traveled all the petrol pump, still we are getting a required fuel greater than the extra fuel. It means we can't travel that, we can't travel in this particular we can't travel all of the petrol pumps whatever petrol they have. That was the condition I'm checking at the last. if my because you can understand, right? Just logically you understand, if my required fuel, which has negative values, if it is greater than the extra fuel, it means we can't travel, right? We can't travel from the where we are starting. Does it make sense to you, Hariharan? Like if you have 4 liter petrol and you have to travel 5 kilometer, you can't travel, right? Right? That's what we are tracking it there. In the required fuel, we were tracking the minus part, and in the extra fuel, we are tracking how much we have already tracked or how much we have already traveled. But yeah, if it becomes zero, it means we have already traversed everything. If it becomes zero, we have traveled everything. It means we have come to the starting point. We have come to the starting point from where we have started. If it becomes zero, you can try with some examples where it will become zeros. Okay. Okay, guys. So let's wrap it. I know that question was interesting, the gas problem, and then we started a little bit about trees. Welcome, Vishal. That's what I was expecting. Everyone should not fear it now and start solving more and more questions, because this tree and graph, guys, very much important. And in this tree and graph, you guys will see everywhere we are going to use queues and stack. More queues, less stack, but more queues. All of the assignment problems, those are also going to be queues or stack. Lot of problems we are going to solve in trees. You guys will see most of the places we are going to see queues. Okay. Okay, so that's all, guys. Let's meet tomorrow and we will continue our revision questions. Okay. Have a good night. Bye bye.